Struggling with math? You're in the right place. Welcome to Explaining Mathematics, the channel where we simplify tough problems, break down complex formulas, and turn confusion into clarity. From basics to advanced topics, we explain it all step by step. Let's start solving.
Hello and welcome. So, if you're deep in calculus, you've probably met some problems that just look like absolute monsters. Well, today, we're going to talk about a super powerful algebra tool that basically lets you tame those monsters and break them down into tiny, manageable pieces. Let's dive in.
Okay, take a look at this thing. It's pretty intimidating, right? You've got this messy fraction inside an integral, and, your first thought might be U substitution or maybe integration by parts, but nothing seems to fit, does it? So, yeah, where do you even begin?
And this is a super common thing with integrals that have these rational functions. Just a fancy way of saying a polynomial divided by another polynomial. They look messy, they feel like they're designed to be a total roadblock. But what if I told you there's a secret to it?
And here's the secret. The hardest part of this problem, it actually has nothing to do with calculus. The real trick, the real challenge, is the algebra of that fraction itself. If we could just rewrite that fraction into something simpler, the calculus part becomes an absolute breeze.
And that is where our hero of the day comes in. Partial fraction decomposition. This is a pure algebra move. It lets us bust up that complicated fraction before we even think about touching an integral sign. It's all about simplifying the problem first.
So what is it really? Well, it's just a method for taking one big, clunky, rational function and rewriting it as a sum of much simpler, much friendlier fractions. You can think of it like the ultimate divide and conquer strategy for math problems.
And this, right here, is the big aha moment. This is the whole idea in a nutshell. Instead of trying to wrestle with that one nasty fraction on the left, we're going to break it apart into these two simple pieces on the right. And integrating those, way easier. The whole game is just figuring out what those numbers a and b are supposed to be.
So how do we actually pull this off? Well, it's not magic. It's a really methodical, four-step process that's going to guide us through pretty much any of these problems.
Here is our roadmap to victory. First, you check the degrees. Second, you factor that denominator. Third, you do the actual decomposition, the algebra part. And then finally, the easy part. You integrate the simple pieces. Let's actually walk through this with that problem we started with.
All right, time to face the beast from the beginning. It looked pretty scary a few minutes ago, but now we have a plan, right? We have our four-step method. Let's do this.
Step 1. Check the degrees. Okay, so the top, the numerator, x minus 3, that has a degree of 1. The bottom, the denominator, has a degree of 2. And since 1 is less than 2, we are good to go. This is a crucial first check, by the way. If the top were bigger, we'd have to do long division first. But hey, we can skip that here. Perfect. Step 2, let's factor that denominator. So we're looking for two numbers that multiply to positive 2 and add up to negative 3. And yep, that's going to be negative 1 and negative 2. So our denominator breaks down neatly into x minus 1 times x minus 2. These are the building blocks for our simple fractions.
And now for the main event, the decomposition itself. We take our original fraction and we set it up to equal some unknown number a over our first factor, x minus 1, plus some other unknown number b over our second factor, x minus 2. Now the puzzle is just to solve for a and b. And finally, we get to step 4, integrate. After a bit of algebra, we find out that a is actually 2 and b is negative 1. So we replace our original ugly integral with this much nicer one. And look how easy this is. The integral of 2 over x minus 1 is just 2 times the natural log of x minus 1. The integral of negative 1 over x minus 2 is just negative natural log of x minus 2. And that's it. We did it. We broke down the monster and we solved it.
Okay, of course, the world isn't always filled with such nice, simple problems. Sometimes denominators get a little trickier. You might get repeated factors, like an x minus 2 squared, or maybe quadratic factors that you can't break down any further, like an x squared plus 1. So what do we do then?
Well, the basic idea is the same, but the way we set up our fractions changes just a little bit. This slide lays it out perfectly. If you have a repeated factor, say x minus 1 squared, you actually need a fraction for each power. So you'd have one for x minus 1 and another for x minus 1 squared. And if you have one of those quadratic factors you can't break down, the numerator isn't just a simple number anymore. It has to be a linear term, like ex plus f.
And I absolutely love this quote from the source material.
It's just a great, reassuring little note for any student out there. Because, yes, while these super complex cases do exist, the algebra can get so just tedious that you very rarely see them pop up on an exam. So it's good to know the theory, but really, don't lose sleep over it.
But here's the really cool thing. Partial fractions isn't just some one-trick pony for these specific integrals. No, this technique is way more useful, and it pops up in some pretty surprising places in calculus.
I mean, for example, what on earth could splitting up algebraic fractions possibly have to do with trigonometry, right? They feel like they're from completely different mathematical worlds.
Well, check this out. Take the integral of secant of x. It's a standard trig integral, but it's famous for being a pain to remember. But with a really clever u substitution, letting u equal sine of x, the entire problem magically transforms into the integral of 1 over 1 minus u squared. And what is that? It's a rational function. It's a perfect candidate for partial fractions. It's just an amazing, totally unexpected connection.
So, to wrap everything up, just think of this process as your personal toolkit. Anytime you see one of these messy rational integrals, just run down this checklist. Make sure the degrees are right, factor that denominator, set up the correct form for your fractions, find those constants, and then rewrite and integrate. You got this! And this really leaves us with a bigger, more powerful idea, doesn't it? Partial fractions teaches us this amazing problem-solving philosophy that a huge, complex, intimidating problem can almost always be solved by just breaking it down into a sum of its simple, manageable parts. So the real question is, what other challenges in math, or maybe even in life, can be conquered with that exact same strategy?
If this video helped you understand the topic better, don't forget to like, subscribe, and turn on notifications so you never miss a lesson. Comment below what topic you want explained next. Thank you for watching Explaining Mathematics. See you in the next problem.